Hi everyone, this is Mr. Wayne here, if you couldn't figure that out here. I am here to do a fun little science experiment with you guys right here before winter break, where we're going to talk about atmospheric pressure by doing kind of a fun representation here in the lab using some just ice and water that's in this bucket right here. We got a couple tin cans over here on the right side on a hot pad, and a few different items that we're going to be talking about here. So this is one of those fun experiments that you guys can actually do at home. So all you would need to have at home is you need a bucket of some kind that's filled to the top with ice and water because you want it as cold as you can get it. A stove top that you can heat up, and normally given like one of those glass tops would probably be the most beneficial or the easiest to use. But if you have a coil top, you can use that too, but it's a little more tricky. And then you just need a couple pop cans or cans that you can fill a little bit with water and go with that. Oh, yeah, that's fine. I can leave that. So, with the experiment here, after you have your water, after you have your ice, you have your tin can, you have your stove that's turned on, ready to go, the thing you have to do is make sure, first off, that your can is completely empty. You don't want to have any pop or anything left in there. But after it's empty, you want to put a little bit of water at the bottom. Because what we're going to represent here is inside this can, and this is going to be one of the first kind of questions here, is as you're looking at the can here, there is a little bit of water at the bottom. And you can see that there's a little bit of steam that's coming off of these cans as they're heating up here. But besides the water at the bottom, what else do you think is inside that can? Now remember, we emptied the can out, there's nothing else in it besides that little bit of water at the bottom. But think about what's inside of this. You know, what else is inside the can besides just that water? Now, what we're doing here is by heating this can up, we're causing all the water at the bottom to turn into water vapor, to heat up, to evaporate kind of out of the can. Now, as it's doing that, it's going to be forcing their air out because it's going to be taking up more space here. So as that's leaving, when you think about the different states of matter, which we did talk about, at least in 8th grade we've talked about, in 7th grade you probably has as well, but when you think about the states of matter, what takes up more space? Does gas take up more space, or does water take up more space? And that's going to be kind of a big key component in this experiment. Now, what we have here is we have, being that it's heated up, we have all the molecules, we have all these things that are moving really quick, they're moving fast. But now, when we take this can and we put it down in this cold water here, we're going to basically slow things down instantly. And then we're going to allow this pressure that's above us, this air pressure, to come back in. And by doing that kind of experiment, we can see the pressure from our atmosphere pressing down on here. So we're going to take this can here at the bottom, and once I take it off the pad, I'm going to take it and put it immediately in the bucket. We're going to see what happens. So once we get this kind of drained out, the can is no longer filled or full. It's been crushed, it's been condensed. So what do you think happened here? You know, what would have caused the can to just crush down like it did? So let's try it one more time on one that's been on here a little bit longer to see if we get a bigger reaction out of this. Same thing. So it's been crushed down, it's been pushed down. So, what do you think happened, or kind of what process or what activity happened in these cans? Oh. Yep, a little bit. So, let's try this third one. Ooh. That was the best one. Alright, thank you guys.